All right, so last time we were talking about compound shapes with the ice cream and stacking things on top of each other. Today we're going to be talking about taking things away from the middle of something else. So the best example of this is pipe, uh, like a big concrete pipe, something like this. Um, or maybe the better example in today's society is actually toilet paper. So let's never mind. Let's go back and look at the toilet paper. Let's do this instead. So, couple of things about the toilet paper. You will notice that the toilet paper is a cylinder, and then it's got a cylinder missing in the middle where the tube is. So we're going to go ahead and work up a model of this. And so we're going to start off with our toilet paper, where we've got this hole in the middle, right? Where we've got a hole in the middle that goes all the way down, and then all the way around the outside. Let's see if I can make that all work here. All the way around the outside, we have the toilet paper, and then that hole kind of goes all the way down to the bottom, right? And then the toilet paper also goes all the way down to the bottom, and we've got it that kind of goes around something like that. So we're going to talk about a regular roll of toilet paper here to figure out how much is on, what the volume is of the regular roll of toilet paper. So we're going to start off with a couple of measurements. I have looked this up. These are somewhat official. So we first off have the tube. The tube right here has a 2-inch diameter. So a 2-inch diameter on the tube. The A whole roll of toilet paper has about a 5-inch diameter. And then average on height ranges anywhere. It can be 4 or 5 inches, depending on whether you're getting cheap toilet paper or bigger toilet paper. So we'll just go with 4 inches as kind of a standard size. Sometimes it's 4.5, all those options. So what do we need to do here? Well, first off, we're going to have to figure out how big the tube is and subtract that from how big the overall roll is. So let's start off by figuring out the overall roll. One thing to note right here, what we have, these two numbers, those are diameters, they're not radiuses. So as we talked about earlier, the radius is half, diameter, the radius is half of the diameter. So we double the radius to get the diameter. So we can take the diameter, cut it in half. So really, this has a radius of 2.5 inches, and the inner circle here has a radius of 1 inch. And then we're looking at 4 inches down. So once again, what are we going to do? These are like circular prisms. We need to get the area of the top half. So radius squared times pi, and then just multiply it by the height. And what we need to do is we need to take this and subtract that from it. So we have radius, pi, height for each of these. So to go ahead and let's go ahead and fill this in. Our radius here is 2.5 squared, and our height is 4. And here our radius is 1, and then squared, and our height is 4. So we're going to go ahead solve this out. 2.5 squared. Probably again should have solved that before coming in here and making sure that I already had the answer down right. But we've got calculators and that's what they're for. So 2.5 times 2.5 or 2.5 squared is, so we have 6.25. That's a point. 6.25 times 4 times pi. So multiply that times 4, and we're left with 25 pi. And then down here, 1 squared is 1 times pi. We end up with 4 pi in the middle that we have to get rid of. Now we can just go ahead and subtract these. If you have 25 pi, you're taking away 4 pi. We can go ahead 25 pi minus 4 pi. And that's going to give us, now remember, we're not taking away the pi here. We're saying we have 25 pi, and we're taking away 4 pi. That leaves us with 21 pi. So our actual volume here is 21 times pi, or 21 times 3.14, giving us a volume of approximately 65.94 inches cubed, cubic inches. And so that's basically how we deal with that. We figure out each of the shapes, and then we go ahead and take away whatever the shape that's missing from the shape that exists. And we could do this with any combination. You could do it with if you had a sphere and inside of a cylinder, you could do that and like subtract the air from inside there and see what the difference is. So that's really all you need to do in order to deal with these subtractive compound shapes like pipes.